book. 1-5 is the applications, so they're difficult for that aspect. 1-6 is difficult because there are other types of equations. So I think we may have talked about them, but I'm going to set them up out of 1-5, and then I'll leave them for you to finish. So question number 7. Out of 1-5, it says the sum of the squares of two consecutive even integers is 500. Let me move it up so we can see here, and 80. Okay? So what does that mean? Well, first off, what kind of integers do we have? We've got even, right? So is the gap 1 or is the gap 2? Okay? They're even or odd have a gap of 2. So even or odd, they always have a gap of 2. So in this case, we're going to have the first number, x. The second number is x plus 2. Is everyone okay with that so far? Now, what does our equation look like? Well, it says the sum of the squares. So sum of the squares, that would mean the first number squared plus the second number squared is going to give you 580. Is everyone okay with how I got to that step? Now we plug our values in. So the first one, what do we call the first one? X. So that means we square it. So that's going to be x squared. What about the second one? Okay, what is it going to be? It's going to be x plus 2, quantity squared, and that now equals 580. And how do we finish it? I'll do one more step, and then I'll leave it for you to finish. What we're going to look at next is we're going to take that x plus 2, quantity squared, and we're going to have to FOIL it. So these require foiling, checking your solution, so lots of things to do in this section. So we'll FOIL this out quickly, and that's going to be x squared plus 2x plus 2x plus 4, which is then x squared plus 4x plus 4. And what do we need to now do? Well, we need to go ahead and combine like terms and move that 580 over. And we now have x squared and x squared, so that makes it a 2x squared. And then we still have a 4x in the middle. And then we've got 580 that's negative, and that 4 to add to it. And so that gives you a minus 576. And before I factor, can someone tell me what I would do next? Okay, if I left this for you to do, what would you do next? Before you start factoring, what would you do? You look at the numbers here. What do they all have in common? 2. So before I try to factor, what do? Divide by what? 2. So go ahead now and divide by 2 everywhere. And that leaves you now with x squared plus 2x, right? And 576, it's even. We divide it by 2. It leaves you with a minus 288. That equals 0. And you should be able to finish it from there, right? Now, how many answers are you going to get? You can have a positive answer, right, and a negative answer, 2 of each. So you should end up now with a total of what? Total of 4 answers. 2 positive numbers, 2 negative numbers. But that's as far as I can go on that one, right? Got it down to where it's the equation. You should be able to factor it out pretty quickly and pretty easily here. Question 8. And there are many different types of questions in 1-5 to look at, different types of problems. This one's going to involve the Pythagorean theorem. So 2 cars leave an intersection. One travels north, the other east. When the car traveling north had gone 18 miles, the distance between the cars was 6 more than the distance traveled by the car heading east. How far had the car heading east traveled? So we've got two cars. We've got a car going north, and we've got a car going east. And then we've got this here, this dotted line, and that dotted line, that represents the distance between them. The shortest path between 2 points is going to be a straight line, so that's going to be the distance between them. So what do we know here? When the car traveling north had gone 18 miles, so that means this one is what? 18. The distance between the cars, that's this, was 6 more than the distance traveled by the car heading east. So the distance of the east car, we don't know. That's unknown. And the distance between them is 6 more, so that's x plus 6. And this is your A, this is your B, and this is going to be your C. Right? The diagonal is always the C. And we know from our Pythagorean theorem that a squared plus b squared equals c squared. And that's 18 squared plus x squared equals now x plus 6 quantity squared. And I'm not going to finish it for you, but how would you go about finishing it? Well, what do we need to do with that x plus 6? We need to take it and we need to FOIL it, don't we? So we'd FOIL it. Now, the x squareds may cancel out because I think they will, and that's going to make it linear. So it should be very easy to solve. You should not have to factor it because those x squareds, well, they should cancel. But you could finish it from there. Okay, so FOIL this out. Move the x squared over, it'll cancel it out, and then you can finish it from there. Question 10. I think I set this one up last time, but we'll go over it again, and I'll set it up and go a little bit further. So a building needs a ramp to make it handicap accessible. By law, the ramp must run 10 inches horizontally for every 1 inch of rise. If the surface of the ramp is 48 inches long, how far above the ground is the inclined end of the ramp? Now, what we have here is a 10-to-1 ratio. And what does it mean if I say it's a 10-to-1 ratio? Well, that means if I go 10 inches across, I go 1 inch up. If I go 20 inches across, I go 2 inches up, and so on, right? It's a 10-to-1. So one of them, the vertical part is going to be unknown, because this is what we've got here. We're going to set it up, and we're going to be applying, again, our Pythagorean theorem. So we don't know how tall this ramp needs to be, do we? Right? The edge there to the building. And we don't know how long it needs to be either, but we know it's 10 times as much. And the piece of plywood that we put over to make the ramp is the 48 inches here. Is everyone okay with how I got that? And this is question 10. Right, because it's a 10-to-1 ratio. That means for every 1 inch of rise, I go over 10 units. So if you had to go over 10 inches, that would be 100 here. If you went up 10 inches, you'd have to go over 100. The length of that board is 48. Now again, it's a triangle, so what do we know? Well, we know we're going to apply the Pythagorean theorem. So now we plug our pieces back in. So we've got 10x quantity squared plus x squared equals now 48 squared. Be careful with that square because that square has to be distributed through. So 10 squared, well 10 squared then makes it 100. So that's going to be 100x squared plus x squared equals, we've got that 48 squared, and we'll need a calculator. 48 squared is 2304. Are you with me so far there? Now we're going to add these together, and that's going to be 101x squared equals 2304. How would you finish it? If I gave you this equation right here, and I said finish it, what would you do? Okay, solve for that x squared, right? So the first thing you would do is you would divide it by what? 101. Okay, and then how would you get rid of the square? Square root. So divide both sides by 101, and then take the square root. Use your calculator, because it says here what? It says round to the nearest tenth of an inch. So that means you use your calculator. You don't have to break up the roots. You just use your calculator and round to the nearest tenth of an inch. So divide and then take the square root. And that should let you finish it from here. But it's mostly done. So just divide and take your square root. Don't worry about the negative answer because this is a height. And can a height be negative? No. So the only one you really need to worry about is the positive case. All right, did we have any others out of 1.5 to look at? Or what about 1.6? Do we have any out of 1.6 to look at? We didn't cover them all last time, but we made good progress through them. Anything else out of 1.6 to look at? Okay. I'll pick two of them just to make sure we're on the right track. Remember how these are done. I'm going to work out two of these. So I'm going to work out 7 and 11. Just to make sure that we remember how these are done. You really need to make sure you keep up with the homework. And if you don't ask questions, then I don't know what we struggle with, but I want to make sure we remember, so I'm going to work out a couple of these. We'll do a fraction one, and we will do a square root one. And this is question 7 from your homework. Now remember our step-by-step procedure. This is a rational equation. So the first thing we need to look at is see what numbers will not work. What numbers are not in the domain? Which numbers give me division by 0? And what can we do to factor? Well, what about this piece right here? Okay, x squared minus 8x. Does that factor? Yes. What can I factor out of it? Let's rewrite it first. What can come out of here? The part I've got underlined in green. What can come out? Okay, an x can come out, and that's going to leave you with an x minus 8. And now everything has been factored. So let's take a moment to see what numbers are not in the domain. Well, how do we figure out what numbers are not in the domain? And what does that mean? When I say numbers not in the domain, that means division by 0. And we cannot have division by 0. So we look at each denominator. And what's our first denominator? x minus 8. So x minus 8 equals 0. What number then is not in the domain? 8. Move it over and solve, right? So 8 is not in the domain. What about the other one? The other one down below is 0. So what two numbers cannot work? 8 and 0. Why does 0 not work? Because it gives you division by 0 there and there. Same thing with 8. 8 minus 8 makes it 0, and we can't have it here, and we also can't have it there. So that's the first thing you always do before you clear out and remove any fractions. Now, once we've gotten that figured out, now we need to clear the fractions. And I factored it to make it easier. So what am I going to have to multiply this by? Does anyone want to take a guess as to what I need to multiply this by to clear out all of our fractions at once? Anyone want to take a guess as to what I would put out in front of here?
8x.
Yep, x minus 8. Okay, that's part of it. And what else? And an x. So you'll want to take out an x. That's going to clear that one and that one. And an x minus 8 would take care of that and that. So you have to use both. Now we'll go ahead and finish it. So distribute through. Take your time and cancel. So when I distribute through, the x minus 8's, those cancel, don't they? So the first piece is simply going to be 8x squared. Right? So those canceled there. But an x and an 8x makes it an 8x squared. The next one, the x's cancel, and that leaves you then with a minus 4 times x minus 8. And what about the other side? Well, it completely cancels. So the other side is easy. It is a 32. I'll do one more step, and then you'll be able to finish it. So distribute that minus 4 through. So that leaves you then with 8x squared minus 4x. Negative and negative makes it a positive 32. And that equals then 32, doesn't it? I'll go ahead and work it out just so you see what's going to happen here. Where would I begin? If I gave you this equation, what would you do? I would not probably try to set it to 0. Why would I not set it to 0? It does have a square in it. All right, but what about that 32 on the left and the right? Those will go away, won't they? So if I move that 32 over, what's that going to leave me with? If I move that 32 over, that leaves you with 8x squared minus 4x equals 0. Now, how would we go ahead and finish this one out? Well, we need to solve it by factoring. So what can I factor out of the left-hand side? Can someone tell me? Someone said it. I can take out a 4x, right? And if I take a 4x out, that leaves me with a 2x minus 1 equals 0. Is everyone okay with that so far? Now, we are going to get two solutions, but only one of them is going to work. Because my first one here is going to be 4x equals 0. So x equals 0. Now, why does x equal 0 not work? Not in the domain. So that one doesn't work. What's the other one? The other one is 2x minus 1 equals 0. So 2x equals 1. So x then equals 1, what? 1/2. And is 1/2 a viable solution? Yes, because what two numbers will not work? 8 and 0. So 0 did not work, but the 1/2 will work. So that's why I picked that one, because there are two solutions, but only one of them will actually work. And again, these are difficult because there's lots of different steps to go through and work out. Now, there are lots of other ones like this one for you to finish on your own. So you'll do all the others the same way. Let's now talk about question 11, because there's several of these also. So we talked about a couple of different types of equations last week, right, on Thursday. So we did the rational equations, which were the fractions, and we cleared our fractions, and we saw what numbers could work. This one has a square root, so we think in terms of opposites. So what's the opposite of a square root? Well, the opposite of a square root is a what? What would I use to get rid of the square root? I have to use a square, right? They're opposites. Now, what's going to happen when I square both sides? Well, when I square both sides, we also have to square that 16. So we're going to have to square both sides. And why are we doing that? We are doing that to get rid of the square root. So we've got to make sure that we get rid of the square root there. $16 squared, if we need to, we can use a calculator. So 16 squared, that's that 256. So this side's going to come out to be 256x squared. And what about the right-hand side? Well, it is 1 minus 24x, right? Now, what are we going to do from here? Well, we need to go ahead and set this equal to what? 0. So let's do that. Watch your signs. A lot of times where students make a mistake is it's in the signs. So now we've got 256x squared plus 24x minus 1 equals 0. How would we factor this one down? Does anyone know how we factor that down? Right, okay, thank you very much. Is that your, yep. Yep, I will take that, and thank you very much. And I will get that graded for you this afternoon. Okay, so what am I going to do from here? We've got it set to 0. We need to factor it. Okay, and that 256, well, that's a pretty large number. First times the last. That's a minus 256. So we have a negative there. And what do we know about our signs? That's a minus 256. So what do we know? Are the numbers positive, negative, or are they different? Different. Okay. And which one's larger? Okay. Yep. Plus should be larger. Minus should go down below. So what are we going to now do? We're going to try to find the numbers. It's even. Let's try, I would say start with an 8. You can try different numbers till you find it, but let's see what an 8 does for us. 8 and 32. And that happens to be what we want because we want a difference of 24. So we need a positive 8, or sorry, let me write them in the right order. A positive 32, right? And a negative 8. That way we get the signs in the correct order. You always write the larger one first. And what does that now leave you with? That leaves you with a 256x squared. We have a positive 32x. A minus 8x minus 1 equals 0. And what can we do next here? Does anyone know what we would do next? So I broke it up. What can I factor out of what I got under? Does anyone know what I can factor out of here? I'm going to show you something easy, and this is going to help you whenever you have to factor. When we look here, we have a 256 here, all right, and it needs to match up with this 8 over here. So what is 256 divided by 8? This helps you sometimes see what you need, right? We need to make sure it's an 8 to match up with that one. So when I did that, I took that 256, all right, and I divided it by 8, and that gave you what? 32. So we're going to factor out a 32x, because you have an x in common as well. And that leaves you with an 8x plus 1. Do you see how I got the 32? Very important that we know how to factor. We know all the different tricks. So when you've got something like this, I look at the first two, and I say, okay, this is 256, this one's an 8, 256 divided by 8 is 32, so we'll take out that 32. What do we know about the last two pieces? Well, these are both negative, so that means I can take out a minus 1. And that leaves you then with an 8x, when I switch my signs, plus 1. So now what do we've got? What do we have for our answers here? Our possible answers. Well, these are the same. So that is then 8x plus 1. And what's left over? 32x minus 1 equals 0. And we've got 8x plus 1 equals 0. So 8x equals negative 1. So x then equals a negative 1/8. What about the other one? 32x minus 1 equals 0. 32x equals 1. So x then equals 1 over what? 32. Now, these may or may not be the answers. You have to check them. So check them back in the original. So you've got to check them all back in the original. I will do one of them. You're going to have to check the other one, just so you see how to do these. I picked this one specifically because this one has a fraction here. And how do we work with the fraction inside of a square root? Well, the easiest thing to do is going to be convert that fraction to a decimal. So we've got x equals negative 1/8. And what would that be as a decimal? It's going to be easier if we use a decimal here. That's 0.125, and it is negative. Now, if I want to check them, you're going to have to check the 1 over 32. I'm not going to do it for you, but you're going to have to check it. So we're going to check it back in this, back in the original. The original is 16x equals the square root of 1 minus 24x. We plug our values in. Okay, so we're just plugging our values in. So there's the original, right? We have to plug in our value of x and use the decimal equivalent. And then we see if the sides are the same. So we multiply together. So 16 times that minus 0.125. That comes out to be a minus 2. What about the other one? Well, we've got 24 times a 0.125, and it is negative. So that's 1 double negative makes it positive 3. 1 plus 3 is 4. And what's the square root of 4? 2, but does 2 equal a negative 2? No. So therefore, we know what? This does not work. This is false, right? So we now know what? When we work this out, we know that 1/8 doesn't work. Now, 1 over 32 will probably work, but you need to check it using the same method. Make it a decimal, plug it in. Normally, 1 works, 1 does not. But they can both work or neither one of them can work. So whenever you get answers in these square roots, you find it. If it's a fraction, use the decimal equivalent, plug it back in. If the sides match up, it's true and it works. If the sides do not match up, then it's false. And it'll usually be something like this, opposites and signs where it's not true. So you're going to have to check the other one, but it probably will work. Okay, you've got 2 solutions, and this one probably will work, but I want you to check it and make sure. So plug it in, check and see if it works or not. So that's for you to finish. Our goal today is going to be at least get through 1.6. We may go into 1.7. We'll just see how much time we have, but we need to make sure that we at least get through 1.6 today. So let's go ahead and now start some out of 1.6. And we're going to now begin with some of the applications. And then we'll go back and we'll do the substitutions. Okay, so let's look at 1.6, and we're going to talk about the applications. We're going to talk about the work questions, work problems. Now, when we talk about these work questions, we're going to be looking at them in terms of how much work or percentage done per hour. So work per minute, whatever it might be. It's a ratio over the time. So when we do these, we have to make sure we set them up as 1 over. How much is done per hour? So if we did, let's say we painted a house and it took 8 days to paint a house. How much work was done in 1 day? If it took 8 days total to paint the house, then in each day we do 1/8 of the house, right? You look at it as how much is done per unit of time. So if it's 8 days to paint the house, then every day we paint 1/8 of it. If it's 5 days to paint the house, every day we paint 1/5 of it. Now, what happens is you can have either someone helping you, which would speed up the process, or you could have some way that it's slowing it down. So like draining and filling of a pool. When you add water in, that's filling, that's positive. When you drain it, it's negative. But again, we look at how much it takes as a fraction of the time. So it's always over 1. So I'll pick a couple of these from our textbook here to go through. And these actually are very simple compared to some of the other applications. And these are our problems involving work. So let me find a couple of these out of our textbook to look at. Okay, so let's look at question 37. And this is on page 165. So question 37. And what we're looking at here is we're looking at painting a house. Now, when we look at these, we need to make sure that everything is done per hour. That way we can add them together. So when we look at these, we have to figure out how much work is done per hour in this case. Could be per minute or per day, but this one's per hour. And again, these are pretty easy to set up. So we're looking at painting a house. If Joe can paint the house in 3 hours, and Sam can paint the same house in 5 hours, how long does it take them to paint it together? So let's take a moment to look at this one in terms of common sense. If Joe can paint this house in 3 hours, what do we know about our answer? Our answer has to be what? Has to be less than 3, right? Because Joe can paint the house in 3 hours by himself. Now, if he has a helper, what do we know? Helper's going to make it go faster. So our answer should be less than 3 at the end. Now, I can't just add the 3 and the 5 together because that doesn't work, because think about what we've got. 3 is a smaller number, but Joe's painting it faster. It's opposite. That's why we have to use reciprocal. That's why we have to figure out how much work is done per hour so we can add them together. It's actually very, very easy to set up and to work through. So we've got 2 people and they're working together. Now when they work together, they're going to add together. So we have Joe and then we have Sam. Now, what do we know about Joe? Okay. Joe, it takes him 3 hours to paint this house. So how much is done in 1 hour? Well, how much of this is done in 1 hour? If it takes him 3 hours, then 1/3 of it is done in an hour, right? So in 1 hour, he's painted 1/3 of this house. Do we know the time? No, we don't know the time of them working together. So our time is going to be X. What do we know about Sam? Okay, so Sam's a little bit different. What do we know about Sam? Sam takes longer to paint the house. And Sam, it takes him 5 hours to paint the house. So how much is done in 1 hour for Sam? It's going to be 1/5. Okay? And what do we know about the time? Do we know the time? Nope. So that again is a X. Now we are going to try to build our equation here. And we're going to look at these. Just like we did with the mixture and the investment questions, they're going to go together. So they multiply together. Joe. Okay. How much does Joe do in an hour? 1/3 of the house. How long does it take him? Unknown time. So Joe, when we multiply, would be 1/3 X. What about Sam? Sam is 1/5 X. They're adding together. And this is going to equal 1. Why does it equal 1? That 1 represents 1 house. Or 100%, right? So it's always going to equal 1 because we're going to have it equal 1 house or 100%, or filling up 1 pool, whatever it is, it's always going to equal 1. Now, how do we clear out the fractions and solve? Well, we have a 5 and we have a 3. So least common denominator of 5 and 3 would be what? Least common denominator of 5 and 3, they have nothing in common. We're going to have to multiply it by a 15, right? That's going to clear my fractions. 15 divided by 3, that makes it a 5x there. 15 divided by 5, that makes it a 3x. And 15 times 1, that makes it 15. We're going to go ahead and add these together. And that is 8x equals now 15. We'll divide by our 8. And what's my answer? X equals 15 over 8. And you can leave it as a fraction. Hours. Now, that makes sense because what do we know about our answer? Our answer has to be less than what? Less than 3. What about 15/8? All right, well, 15/8 is what? Okay, 15/8 is 1.875. Is that less than 3? Yes, so we know we did it correctly. And you can leave it as a fraction. Now that's when they add together. But you can also have it where they subtract from each other. And an example of that would be filling and draining of a pool. So question 41 is a subtraction question. So 41 is a subtraction question. So an inlet pipe can fill Blake's pool in 5 hours. Let me fix the focus here a little bit, maybe. Here, I'll fix the focus. Let me fix the focus so it's going to be right here. So we're going to be looking at filling and draining the pool at the same time. So an inlet pipe can fill Blake's pool in 5 hours, and an outlet can empty it in 8. In his haste to surf the internet, Blake left both pipes open, and we want to know how long it's going to take to fill this pool. So water's going in, and water's also going out. And this, by the way, is on page 165. And we are looking at question 41. So we have water going into a swimming pool. And then we've got water going out. Now when water goes in, that's going to be plus. When water goes out, that's going to be a minus. So what do we know here? We know it takes him 5 hours to fill this pool. Okay, so 5 hours to fill would be, how much is done in 1 hour? 1/5. You have to always make sure you convert it into a fraction there. Again, the time we don't know, so the time is x. What about the draining? When we drain this pool, that's subtraction. And how long does it take us to drain this pool? It takes us 8 hours to drain the pool. And so how much is drained in 1 hour? 1 hour, it's going to be 1/8. And we'll use a minus here, because that's going to be minus to represent the drain. And again, the time we don't know, so we'll use an x. Let's take a moment to think about our answer. If it takes 5 hours to fill up this swimming pool, right, on its own, our answer should be bigger than 5, right? Because if you're draining some of it out while you're filling it up, it's going to take longer. So our answer needs to be bigger than 5, right? Because you're filling and you're also draining. It takes 5 hours to fill it up, but if you're draining it, it's going to take a little bit longer. So our answer had better be bigger than 5. So let's now build our equation, and then we'll clear our fractions and solve it. So what do we have? We have 1/5 x minus 1/8 x, and what does it need to equal? 1. Why does it always equal 1? Because you are, in this case, eventually filling up one pool. It is always going to equal 1. Now we can finish it. So we'll clear our fractions by multiplying everything by a 40. So 40 divided by 5, that makes it an 8x. 40 divided by 8, okay, that's a 5x there. And 40 times 1, that's a 40. Combine them together, and that's 3x equals 40. divide by our 3. And our answer should be x now equals 40 over 3. And that's in terms of hours, right? So 40 over 3 hours. Now, does that make sense? I think it does, because what do we know about our answer? Our answer has to be bigger than what? Bigger than 5. Well, what about 40 over 3? Okay, if we use a calculator, 40 over 3, well, that's 13 and a third, right? Or 13.3. Is that bigger than 5? Yes, so we know that we did it correctly. These are very easy. They're, I think, the easiest ones in this section. Now we're going to look at some questions in the same section that give us many solutions. The highest power is going to tell us how many solutions that we will have at most. So if you have a high power of 3, that means you can have up to 3 solutions. If your power is 4, then that means you can have up to 4 solutions. So we're going to be on these factoring them, and we're going to be solving them, but we're going to get lots of solutions. And the highest power tells you how many at most you're going to have. So this is still 1.6. And these are where we use a substitution. We factor them and we get our answer by using the square root property. So let's go ahead and factor this and solve. And we'll start off with a pretty easy one. So if I gave you this one here, and I want you to solve it. If this was x squared, what would you do? You would set it equal to 0, right? You would solve it by factoring, and it's very easy to factor. This one is an x to the 4th. So an x to the 4th, this tells me that I have up to 4 solutions. So I'm going to have up to four solutions here. So the first thing I would do is I would set it to 0. And we're going to factor it just like we always would. All right, so we're going to set this equal to 0. And we put our 1 in front. And we should have no trouble factoring this one. First times the last is 1 times 4 is 4. And what two numbers multiply together to give you 4, add together to give you 5. Pretty easy. We're going to use a 4 and a what? 4 to 1. Okay, I made this one easy to factor because I want you to see how you're going to get the solutions. So we're going to use a positive 4 and a positive 1. Now, when we go to factor it, normally we would have x and x here, right? But what about this one? This is x to the 4th. How can we split up x to the 4th evenly? Well, it's x to the 4th, so I can split it up into x squared and what? X squared, right? We split it in half, and then we've got a 4 and a 1. Now, why am I going to get 4 solutions? Well, I am going to get 2 solutions from each set. So let's start with our first one. Our first one is x squared plus 4 equals 0. So we'll move our 4 over. And now we've got x squared equals negative 4. And how would I get rid of the x squared here? Someone tell me what I would do next. Square root. Okay, and this makes us remember what we learned back in 1-3. Whenever we take a square root, we add that plus or minus. But what about the square root of a negative 4? What would that come out to give you? Plus or minus 2i, wouldn't it? So there's two solutions right there. What about the other one? Well, the other one is x squared plus 1 equals 0. So x squared equals negative 1. We repeat the process. On both sides, we take our square root. So that now leaves you with x equaling plus or minus I, doesn't it? Now, why do I have 4 solutions? Well, I have 4 solutions because I've got 2 and 2. So what are my final answers here? Let's write them out. And here's where they all come from. You've got 2i, you've got minus 2i, you've got an I, and you've got a minus I. So I now have 4 solutions here. Plus or minus 2i, plus or minus I. Let's look at one from our textbook, and this is on page 166. And we're going to look here at question number 90. So this one's actually a little bit more difficult to factor. We're going to try our best to factor this one out. So how many solutions should we end up with? We should end up with 4, right? Why 4? Up to 4. Now we may only have 2 because you might have a double root, but we can have up to 4 because that's our highest power. So now we begin again by factoring. This one we'll have to do by grouping. So first times the last. First times the last, that's a minus 75. What again we know about our signs here? Are they positive or are they negative or are they different? They're going to be different. Okay. Plus and minus here. Okay. So what's going to happen here? What two numbers multiply together to give you that 75, subtract from each other to give you that 10? Yep. 15 and 5, right? So we're going to use a positive 15 and a negative 5. And I'll be right back. I've got to go below my nose, but I'll be right back. Go ahead and finish this one up. Now we got that to factor, right? We factor that into our numbers are going to be a 15 and a negative 5. This one, though, we cannot just jump to our factors. We're going to have to do grouping. So that's a 3x to the 4th. Then we have a positive 15x squared. We have a minus 5x squared and a minus 25. What can we factor out of the first two pieces here? Yep, we can take it not just a 3x, we can take out a 3x what? Squared. Always have to take out the highest power. And that leaves me then with x squared Take out that 3, and 15 divided by 3, that makes it a 5, right? So that's what we got there. Next two pieces, these are negative. So let's take out a minus 5, and that leaves you then with an x squared plus 5 equals 0, right? We use the same process. It's just that instead of having an x, we've got an x squared. So now what do we have? When we put these together, we now have x squared plus 5 and a 3x squared minus 5. And we're eventually now going to be able to factor this down and get our 2 solutions from each one, which is then 4 total. So 2 from each one gives us 4 total. So what does it look like for our first 2? Well, that is x squared plus 5 equals 0. We'll move that 5 over. And now we've got x squared equals a negative 5. And how do we finish it? Can someone tell me what to do? We would do what here? Okay, square root. And whenever you take a square root, what does that add on? Plus or minus. So that gives me then x equals plus or minus. Now it is negative here. So when I comes out, square root of 5 is left over. So there's that component. Right, so we factor that out. We work with that piece. What about the other one? Well, let's try the other one. The other one is 3x squared a minus 5 equals 0. So 3x squared equals 5. We'll divide by our 3. And that leaves me now with x squared equals 5/3. And how do we get rid of a square? Again, what do? We take our what? Square root. Okay. And then we also need to do one more step here to get the same answers the textbook has. So we now have x equals plus or minus square root of 5 over the square root of 3. We can't leave it like that because we never want a square root in the denominator. So if you have a square root left in your denominator, you have to rationalize. So to rationalize, we'll multiply this by the square root of 3 over the square root of 3. And that leaves me then with 5 times 3, that's square root of 15. 3 times 3 is 9. And 9 is a perfect square of what? 3. So what does it now look like? For my final answers, we've got 4 of them. Let's write them out and see what we've got. We've got I squared of 5 minus I squared of 5. And then we've got the square root of 15 over 3 and minus the square root of 15 over 3. Now, the only part that's new is here when we rationalize. And if you don't rationalize, it's okay. I would take it like this with the square root of 3 down below. But if you want yours to match up with the textbook, you're going to have to rationalize. And that just means we multiply it by the square root down below, so the square root goes away. It's just the way we formally write things, the correct way. I'll take this as an answer as well. So I would take square root of 5 over square root of 3, but I prefer this one, which is those two. Okay. And now let's see if that covers everything. I think that should cover all now of 1.6. Yep. So we should now be able to at least start a little bit of 1.7. We're not going to get very far in 1.7. But we will at least begin working in 1.7. And again, we're not going to be able to get very far in 1-7 because it's a larger section too. We'll at least be able to get started. Again, sorry they didn't copy out exactly an easy way to work with it, but it's what we've got. So now in 1-7, we're going to talk about inequalities. And we're only going to work through the first 3. We'll do the rest of the next class period. So we're going to do a quick review of inequalities. So this shouldn't take very long at all, maybe 10 minutes at the most. Inequalities, when we go to graph them on the number line, strictly greater than, strictly less than, those get parentheses. Greater than or equal to, less than or equal to, those get our brackets. And positive or negative infinity is also going to get parentheses. So this is a very easy concept. You've done it before numerous times. So when we go to graph these on a number line, strictly greater than, strictly less than, those get parentheses in interval notation. Greater than or equal to, less than or equal to, those get the brackets. Positive or negative infinity, they get the parentheses. Also, when you divide or multiply by a negative number, what happens to the inequality? Does anyone remember? And usually when it's just dividing. But when you divide by a negative, what's going to happen to the inequality? Does anyone remember? Remember, you have to flip that inequality, right? So whenever you divide or multiply by a negative, usually it's just dividing. We don't really multiply much. But whenever you divide or multiply by a negative, you're going to flip that inequality. And we'll do a couple of these. And again, this shouldn't take long at all. These are kind of a nice, refreshing type of question from what we've done before. I'm going to have you graph and write your answers in interval notation. So I'm going to have you graph these and write your answers in interval notation. And we'll do one that's very easy to begin with. We'll do 2 easier ones. And then we'll do some where we have to actually solve. And again, this should be a review. So I want you to graph this and write it in interval notation. The easiest way to remember is you look at which way it points. This is pointing to the left. When it points to the left, we shade to the left. If it points to the right, you shade to the right. Your X always has to be on the left-hand side. So this should be a review, but we still need to make sure we know how to graph these. We've got our -8. It's pointing back to the left, so we're going to be shading back to the left. It is less than or equal to, so that means we use a square bracket. And if it's going back to the left, that means we go back to negative infinity. So what does my answer look like now in interval notation? Well, it looks like negative infinity, reading from left to right, to -8 with a what? With a square bracket. All right, so that's what we have there. Let's do another one. How about X is between a -3 and a +4? Same directions. Graph it and write it in interval notation. This one has already been solved, so there's really not much to do. Put these on the number line. We've got a -3 and we've got a +4, and make sure you put them with the correct symbols. X is in between -3 and +4. At the -3, it's going to get square brackets. And at the +4, it gets parentheses. My answer is in between. So what does that now look like in terms of interval notation? Well, in interval notation, it's going to be -3 with the square bracket. And where does it go to? +4. Now let's solve a couple of these. So let's try and solve this one. This is very, very similar to question 3 from your homework. Different numbers is all it is. Now, normally when we divide by a negative, we switch that sign, right? Same thing with multiplication. When you divide or you multiply by a negative, you're going to flip your inequality symbols. How can I clear out these fractions? I can clear out the fractions by multiplying everything by a what? -3. Okay, so that's going to clear it all out. So let's go ahead and do that. You can just basically cross multiply here. So -3 times -4. Well, negative and negative makes it a +12. You multiplied by a negative or you divided by 1, flip the inequality symbol. Then we have an x plus 9 in the middle, and -3 times +9, well, that's a -27. And we have to then flip our what? Flip our inequality symbols, right? Whenever you multiply or divide by a negative, normally it's just dividing, but it does apply for multiplication as well. Now we need to get the x by itself. So what do we do next? We simply move that 9 over with subtraction. And then that leaves me with 12 minus 9. Well, 12 minus 9, that's a 3. We've got our x in the middle. And minus 27 minus 9. Well, that leaves you then with a minus what? Looks like minus 36, doesn't it? How do we put this on our number line? Now make sure they're in the right order. If you flip the inequality symbols, they flip on the number line as well. -36 is the smaller number. Okay, so make sure it's on the left, because we flipped our inequality symbol, we flipped the order. So -36 is on the left, +3 is on the right, and these both get parentheses. So there's my answer in the middle. And so what would that look like in interval notation? Well, that would look like -36 to 3. We'll do one more, and I'll go ahead and pass out the sign-in sheet. Please make sure you sign the sign-in sheet. And then we'll talk about our homework. So we're going to solve and graph here. And this one will be a pretty easy one to work through. So this won't take us very long at all to go through. We want to solve it. Now, whenever we work with these inequalities, we need to make sure that the x is on the left-hand side. So move that 3x over with subtraction. And move that 5 over as well. 4x minus 3x, it leaves you with a single x. The 5's cancel, the 3x's cancel. 9 minus 5, that makes it minus 9 minus 5 makes it a minus 14. On the number line, here's our minus 14. Which way is it going to go? Or which way does it point? It points to the left, so we shade to the left. Brackets or parentheses here? Which one? Parentheses. And it's going back to the left in this direction. If it goes back to the left, that winds up at negative infinity. So what does our answer look like? It looks like negative infinity to negative 14 with parentheses. And now we'll talk about our homework. So you should now be able to finish 1.6. So you can work through all of those. 1.7, you can only do the first 3. But you can at least try to do those first 3. They're very easy. If you've got 1.5 finished, you can turn it in. If you need more time to finish 1.5, turn it in on Thursday. So if you've got 1.5 finished, I'll take it today. If you want to wait and turn it in on Thursday, you can do that on Thursday.